Okay, so this is day 3 of the worksheet, and so we have this polynomial a function, the rational equation, and we have to find the holes. So to find the holes, we have to factor it out. So and it's given us in factored form, and then we look at in the numerator and denominator which term can be cancelled. So in this case it would be the x minus 1 because it's both in the numerator and denominator. So we take this x minus 1, we equal to 0, and that means x would equal to 1. So that would be our x coordinate for our hole, and then we would take that 1 as the x and then put it back into the function. So everything here, everything x we see here would be replaced by positive 1. And so when we do solve for that equation, we get 3 times negative 2 over 6, which is equal to negative 1. And so that would be our y coordinate, and so that would make us get our hole to be 1, negative 1. That's our coordinate. And for the vertical asymptote, we take the denominators terms that are not factored, so we would just take the x and the x plus 5. So we equal to that 0, and then find x. So we get x equals 0 and then x equals negative 5. So that means that the vertical asymptote would be x equals 0 and negative 5. For our horizontal / slant asymptote, we first have to look at the terms of the numerator and denominator. Since there are 3 terms on top and 3 terms on the bottom, that means the degrees are the same. So then we just take the coefficient of the leading terms, and so when we do factor it out, we get this. And as you can see, the coefficients for both of them are 1, and we would divide that. So 1 over 1 is just 1, so that would mean that the horizontal asymptote is y equals 1, and there would be no slant asymptote. For the x-intercept, we would take the factor or the terms that are on the numerator that are not cancelled out, so that would be x plus 2 and x minus 3, and we take that and then we equal to 0 to find the x. So we get x equals negative 2 and x equals 3, so that would be our x-intercept. So when it's negative 2, y would be 0, and when there's 3, the y would be 0. And so those are our coordinates for the x-intercept. For the y-intercept, we would have to look at the constants after it's followed out. So as you can see, there's the 6 on top, but there's no factor here, so that would mean there is no y-intercept. Yeah, so that would be none. And we can also see that there won't be a y-intercept because the vertical asymptote is x equals 0. So, and for it to be a y-intercept, the y would have to equal to 0, and because asymptote means that the line gets to 0 but never actually meets 0, so there could never be a y-intercept because there's no 0 for y. And so using all this, we graph. So as you can see, there's the vertical asymptote negative 5. There's the vertical asymptote at x equals 0, horizontal asymptote at y equals 1, and then the x-intercept negative 2 and positive 3, and then the whole at 1, negative 1. So we got like this, as you can see that, there's the function, and this is what the graphs look like. So the next question, given this logarithm equation, simplify using the properties log in the graph, and then graph. So as you can see, log x plus 4 minus log 4 plus log 2 plus 7. So we would use the logarithm properties to simplify. First, this is x plus 4 and then minus log 4. So because it's a minus and the logs are the same base 10, we would use a property that when it's subtraction, that would mean that it is division. So we have x plus 4 over 4 as we have here. And then because it's addition to the same base, that would mean it's a multiplication. So we did times 2. And then this 7, since it's not a log, we would just keep it outside like that. So right now we have this, and then we can further simplify by taking this. So 2 over 4 is like the same as just dividing by 2, so we would get x plus 4 over 2, and then that same plus 7, and that would we would factor out like a half, so we get log parentheses half parentheses x plus 4 parentheses plus 7. That would be our simplified form using the log. And I have the same thing over here. This is the simplified using this format. So as you can see, it's the a would be just 1, so we don't really write that. Log parentheses, the b would be this half over here, parentheses x minus h, so like our negative 4, which would make it a positive 4, and then plus k is the plus 7. So now we can graph this. So first, first we can like find the vertical asymptote. How we do that is basically we look back at this equation, and the x plus 4 is here, and we would equal that to 0, and then we would get x equals negative 4. So that would be our vertical asymptote. So as you can see, there's x equals negative 4. And then to find the pivot point, so pivot point is basically where the equation changes like direction, basically. And so we get that by using this equation, like when we can see that it's half x plus 2 plus 7. So this plus 2, it would mean the opposite, so there, it would go to the left 2, and then this plus 7 would just be a like transformation, like slide up 7. So we have left 2 and then up 7. So this is where our pivot point is. And then we can just like plug in y values. So I put 6, 7, and 8 just to get like our estimate of like what direction this function will look like. So I got negative 3.86, which would be over here, and then 16.8, which is like too far to graph, but it's like somewhere over here basically. So we get like the equation is in this direction. So that's our graph, and then we can do the rest of this stuff. So the domain, we go from left to right. We see that negative 4 is asymptote when x equals. So we can see that it really doesn't touch x, but everything. Negative 4, but everything. We have this bracket. I mean, this parentheses, not the bracket, to indicate that it's like 3.99999 forever, but like it wouldn't ever touch negative 4. So we have negative 4 to infinity because of this arrow. It would just keep going to infinity. And then range is from like up to down. So we go here. So as you can see, there's this arrow, so that means it goes from negative infinity, and then here it'll take a long time, but it'll eventually go to positive infinity. So that's our range. The end behavior, as you can see, so as x equals to positive, y also goes to positive infinity, and then as x equals to negative 4, because that's the asymptote, as x goes to negative 4, y goes to negative infinity. And then like just before the asymptote, we already decided how we got that, and the pivot point we already discussed how we got that. So now we have to find the inverse and graph it. So how we do that is basically we take this equation, this is our like normal function, and then we replace the x with the y and the y with the x. So we have log half y plus 2 plus 7 equals x right here, and then we basically have to solve for y, and when we do that we get 2 times 10 to the power of x minus 7 minus 4, and so that would be our inverse equation. And basically from this graph we just take everything and like do the opposite, the inverse. So we would have the horizontal asymptote as y equals negative 4, and then instead of negative 2, 7, we did have 7, negative 2 as our pivot point, because it's just the inverse of all of this. And the same, before we had like negative 3, 3, 8, 6, and negative 2, 7, but now it's 6, negative 3, 8, 7, negative 2, and 8, 16. And so that's our graph right there. For the domain, just the same thing, negative infinity to positive infinity. The range though would be from So as you can see, the domain and range are flipped. So negative 4 to infinity, again with that parentheses, the end behavior is x equals to negative infinity, y goes to negative 4, because this is the asymptote right here, and then as x equals to positive infinity, y equals to positive infinity. The asymptote, we said it was y equals negative 4, and then the pivot point is the opposite, so 7, negative 2. And yeah, that was day number 3.